Electric charge. Students, electric charge is one of the most basic concept which we deal in with electrostatics. What is electric charge? Electric charge is the property which is associated with mass. Electric charge is the property which is associated with mass. But the charge is associated with mass. Mass may or may not be associated with charge. Charge at rest produces electric field. Charge in motion produces electric and magnetic field. Charges are of generally two types. One is positive charge. Positive charge, deficiency of electrons. Like you have a sodium 11. Like you have a sodium. Now sodium loses one electron. If I write here sodium 281, it loses one electron. It becomes Na plus. So it becomes positive charge. It is deficiency of electron by 1, right, as compared to protons. You talk about chlorine. Students, chlorine gets one electron. It is 287. It becomes Cl minus 288. So chlorine is negatively charged. It is excess of electrons as compared to protons. Students, Dufay was the first person who suggested that there exist of two types of charges, and Benjamin Franklin discovered positive and negative charges, and like charges repel, unlike charges attract. Dear students, when you talk about the dimensional formula for the charge is M0, L0, T1, I1, M to dimension 0, length to dimension 0, time to dimension 1 and current to dimension 1. You will put one question. Is charge a fundamental quantity? No, it was when we use MKSQ system, but charge is not a fundamental quantity. Now we use SI system, so therefore current is treated as fundamental quantity. Therefore, we define charge in terms of current, that is product of current into time. So, the possible questions: what is charge? Second, who was the first person to assign there was how many types of charges? Is charge a fundamental physical quantity? Right? Now, students, what is the unit of charge? Generally, we take 1 coulomb. 1 coulomb is equal to 3 into 10 to raise power 10 ESU. 3 into 10 to raise power 10 electrostatic unit of charge. So, dear students, charge is basically a scalar quantity. It is not a vector quantity, and charge is transferable. Like in sodium, electron is transferred to chlorine and Na plus Cl minus, it becomes NaCl. Charge is quantized. Charge is quantized. A body can gain or lose what? Whole number multiple of charge, not fraction of charge. Although now charge is not a fundamental, electron is the smallest particle, but it's not fundamental. We'll discuss later, as electron is also divisible, right? Electrons are also divisibles in quarks, top, bottom, strain charm, all right? So this is an introduction to the concept of charge, and hope this must be clear to you all. Thank you.